Hello everyone, welcome back to MGF1106. In this video, I will jump to another chapter, and in this chapter, we will be discussing another branch of mathematics. And this branch of mathematics it's been developed for a very long time, and first time developed is like more than 2,000 years ago. This one is considered as the classical mathematics. So more than 2,000 years ago, many Greek mathematicians did a lot of research and talk about many different shapes. So the concept we talk about today, the branch of mathematics we talk about today, we call that the classical geometry. Okay, so I'm gonna put here right over here in this video. We will be talking about geometry. Okay, and as I said, this has been developed for a very long time. Many Greek mathematicians. One of them is Euclid. Okay, maybe some of you already heard this name, or some of them Euclid or Pythagoras. Okay, or Archimedes. Okay, and many more. So I cannot list all of them, but this is all the Greek mathematicians. They lived like more than 2,000 years ago already. Okay, so in this video we'll be talking about some entity of geometry. Then in the example we'll be learn how to recognize those entities, and let's see how we're gonna do some calculation regarding to within these the above entity I talk about. Okay, so let's talk. Let's jump into the geometric entity right away. Okay. So we'll put here geometric entity. Okay. Alright. The first entity I would like to mention is point. So this one is point. So point it just represent the location in space. Okay, and this point is represented by a dot symbol like that. So that's a point. Okay, so it represents, this point over here represent a physical location in space. We talk about a two-dimensional space. So two-dimensional space. So the geometry the geometry we talk about, we call it two-dimensional geometry. Okay. Then if we have 2 points, if we have so I'm gonna call this the first entity. And if we have 2 points, then we will have a line. Now we have a segment. Okay, hold on. This is segment. Okay, so a segment is created by 2 points. Okay, and it connected to each other like that. Okay. Okay, so I'm gonna call this a point A, and I have 2 points, point A and point B. Then I have a segment, and this is a full segment because we include the endpoint. And sometimes we have an open segment, mean the point A and B is not included. Okay, so this is an open segment, this is a closed segment, you can say that. Okay. Then as well we have a segment, then we go ahead and extend the segment into both directions. Then we will have a line. So let's say I have a segment like this, Okay, A and B, and I go ahead extend it to both sides using the arrow like that. Okay, then I will have line AB, and the mathematical notation for line AB is this. Okay, and the mathematical notation for segment AB is this. Okay, so this is segment AB, this is line AB. But however, if we just go ahead extend only one side, and we have ray. So let's say we have segment like that. Okay, maybe, but I extend only one direction to. Then we will have ray AB. Okay, ray AB. Okay. Some ray AB, and the ray AB could be this way or that way. It's the same thing. If we don't include one of the point, then we will have half ray or half line. So we will have something like this. But I'm telling you, we barely have something like this. Even we have half line or half segment or half ray, we barely seen half ray or half line or half segment in geometric set. Okay. Entity number 5. So we have ray, we have line, we have segment. Now, if we have two ray, and these two rays have share the same point. So let's say I have ray AB. Okay, and this ray AB over here share the same point A with ray AC. So you see that they share this point over here. Then it creates the space right over here between them. Then this space right here we call that angle. So this is called angle. Angle what? There are two different type of notation for angle. You can put angle A with this symbol. Okay, angle A. Or you can put angle with this symbol also, with the arrow and the BAC. So you see that angle A, the angle will be created by two rays. They share the same point A, so the point A should be in the middle. So you can use this notation or that notation. You know, in many cases, you use three-letter notation because think about it. If you have a geometric shape that is complicated, and many rays share the same point, then it's very hard to know what angle we refer to. Then you have to use this symbol, okay, with three letters, and the angle you refer to must be represented by the letter in the middle. Okay. Now, so there's an angle, and you see that how big two rays opening, it will tell you how big the angle is. Then we call that the measure of that angle. So we're gonna put measure. Notation for the measure of angle will be like this. So measure of angle A. Okay. M representing measure. Okay, measurement of angle A. Okay. And we're gonna talk about this entity more. Okay, but before I jump to the last entity, I think I should put this at the end. Let me see. I can move them. Let me see. I can move them. There you go. I can move it down here. Okay. And I should talk about something before we talk about angle. Okay, so this one should be number 6, and the number 5 entity is a plane. Okay, so plane represented by this shape right here. So this is plane. Okay, let's say that I want to name this plane as this plane P. Okay, and if we have two line or two segments intersect each other, we can define a plane. Okay, or if you have 3 points, on the surface, for example, I can call 3 points over here on the surface A, B, C. Then with 3 points I can define a plane. So over here I will have plane ABC. So I use 3 letters. But that also sometimes we can call the plane. We can use the name over here, plane P. Okay, so 3 points on space. In space we can define a plane. Or if you have two segments or two rays intersect each other, you can also define a plane. Let's say that I have two rays like that. Okay, so I can define a plane. Okay, based on these two rays. Okay, good. So totally we have 6 entities, but the last entity over here, the angle, is more important because you're gonna deal with this very often. Okay, and I talk about the measure of angle, tell you how big two ray opening up. Okay, and we can measure how big is opening up right here using a tool to measure how big the angle is. We call the protractor. Okay, and there are so many. There are several different type of angle, or 7 different type of pair of angle. Let me introduce the first 3 basic angle. Okay, so the first 3 basic angle. So you see that we have right angle. Okay, and it's symbol like that. So this one is 90 degree, and we have acute angle which is less than 90. Then we have obtuse angle between 90 and 20. Then we have a straight angle, sometimes we call it flat angle. You see that we have 2 rays, and we have a flat one. That's also the angle over here is 180 degree. Okay, so these 4 basic angle you will see very often in your homework. Okay, other than this, we also have some pair of angle, and they are congruent to each other. You can have a vertical angle. Okay, a vertical angle. So vertical angle are congruent to each other. So how you get a vertical angle? If you have 2 ray or 2 segment or 2 line, and they are intersect each other, you see that you can create 2 pair of a vertical angle. They are congruent to each other. So the first pair, let's say that over here, we have 1 and 2, and I have angle right here, 3 and 4. So you have 2 lines, 2 segments, 2 that intersect each other. We have 2 pair of congruent angle. Congruent angle means they are the same in terms of measurement. So the measurement of angle 1 and angle 2 is the same. So you can put measure 1. Okay, you can put measure 1. Measure of angle 1 is the same as measure of angle 2. If you can put that way. Or in some textbook, they just put like this with another expression. So they can put angle 1 like that. Okay, equal to angle 2 with the head like that. So they know this angle 1 is equal to angle 2. Other than that, we also have angle 3. So measure of angle 3 congruent to measure of angle 4. Okay, so they are the same in terms of measure. Okay, so if you have vertical angle position, you have two pair of congruent angle right here and here. All right. Other than that, we also have we can also have at least a few pair of congruent angle if we have two parallel line and transversal line. Okay, what if we have something like this? Oops, I don't have enough space here. Let me see, I can jump to another page. Let me see. Oh, before I jump to the parallel line and transversal line, let me to mention one more thing right here. So we talk about angle 3 and 4 congruent, 1 and 2 congruent. However, angle 1 and angle 3 over here is not congruent. The good thing is that if you notice the angle 1 and angle 3, they add them up, it's a flat one. So if they angle 1 and angle 3, when they add them up, they give you 180 degree. And when the sum of two angles give you 180 degree, we call that supplementary angle. Okay, supplementary angle between two angles when the sum is equal to 180. So you see the measure of angle 1 plus measure of angle 2. This is angle 3. Okay, angle 3. This is give you 180 degree, give you a flat angle. So is 3 and 2, 2 and 4, 4 and 1. Okay, so we have four supplementary angle over here. 1, 1, 3, 3, 2, 2, 4, and 4, 1. Okay, so 3, 2, measure of angle 3 plus measure of angle 2 is also 180 degree. Okay, or 2, 4, 1, 4 is also 180. Okay, I'm not writing, but I just show you 2, 4, and 4, 1 also 180. Okay, now if we have the sum of two angles, they're 90 degree, then we will have a complementary angle. Okay, so I have a right angle like this. Okay, and I have another right angle like that. Okay, and you see that it's split up into the right angle over here is split up into two sub angle, right? So I'm going to call this sub angle over here is angle 1, and I call this one over here is angle 2. And you see that if you go ahead and add angle 1, measure of angle 1, and I add to the measure of angle 2, then this instead of give you 180, it give you only 90. So if the sum of two angle and 90. Then we have complementary. Okay. Now the last one, I can create. I can derive many concurrent angle based on two parallel lines and transversal line. So we'll have something like this. Yeah, here you go. So the line L is parallel to line L1, parallel to L2. Okay, and the purple line right here we call the transversal line. Okay, so you have two lines being parallel to each other. You have transversal line. Then you can create a bunch of concurrent angle. Now, for example, 3 and 6. 3 and 6, they are congruent to each other. Okay, 3 and 6 congruent to each other. So I'm gonna just go ahead and delete this. Oh, I cannot delete this. So it's gonna congruent to each other. So 4 and 5 are congruent to each other. Okay, so this is called alternate interior, and 1 and 8 is outside. So this is called is also congruent to each other. 1 and 8 and 2 and 4. Okay, and corresponding is 1 and 5, 2 and 6, 3 and 7, 4 and 8. So we have 4 pairs corresponding to each other, and each pair is each angle over here is equal to another one. We call this one pair. So all of them is congruent to each other. 1 equal to 5, 2 equal to 6, 3 equal to 7, 4 congruent to 8. Okay. Good. All right. So right now, we already know what the angle, special angle, what it looked like. Now let me jump into the first example right away. In this example, it train you to realize all the entity we have talked about so far. Okay, so in this first example, I had a picture like this, and you see that the picture has about 3 lines and about several points here, and we have some compound statement right here, and we want to see what does it mean by this compound statement. Okay, so over here we have AB. This is a line, so we have AB line. Okay, AB going this way, and DC going this way, and we want to find intersection. So AB going this way, okay, and DC go all the way over here. So what we have over here is a array, okay. AB is array going this way on the way here, but DC go all the way over here. So what we can obtain out of this will be what? It will be intersection overlapping. So AD and DC. So when we have a segment, we will have segment AD, right? ADs will be the in common, because you see that AB go on the way this way and DC go on the way this way. Then you see that there's a part right here. This will be shared in common. So our answer will be AD in this case. Now we have BC, so we have half segment BC. So we don't want to include C, we include B, and we want to union with CD. So this one does not include, but this one the C includes, and we want to take union. So answer will be B. Okay, B included, but D is open circle, so BD not included. So we have something like that. Then we have half line and BD or half ray. BD go this way. Okay, B does not include, and C does not include, go this way. Okay, So we want to find union. So you're gonna end up with BD this way, CB. So we're gonna end up with CB, right? BD this way and CB this way. So is it gonna end up with a CB or BC? Okay, and we got a union. So we're gonna have open circle here, and at C, we include, but C over here is not include. So when you take union, so it means that we have to include it. All right. Okay. B includes, D includes. So we're gonna have BC. We have BC included. So you don't need to do open circle like that. So just BC. Okay, BC included. Okay, then we have FC included, FI included. So FC, FI. So you will have when you do union, you're gonna have IC, and you're gonna have a line. Right, you have a line union because union you take everything. So FC go this way, FI go this way, so you're gonna have IC. Then you have BC go this way, it's a segment, CF segment, another segment. So you're gonna have look like we have a triangle right here. So we have triangle BFC. You know, in my opinion, they shouldn't put this question because we're gonna talk about the shape, geometric shape later. But anyway, they put this question out there, so we just do it. And BG this way is ray, and CI is also the rays, and yeah, intersection. So this is the point F. Okay. So we have BD is half ray. We have CB. Is it this one or this one? Oh, okay. So it's different. This is in union. So this is intersection. So CB this way. So we're gonna have CB, BD this way. C. So we're gonna have BC. Okay. We have BD. C not included, CB. So intersection will be BC. This is gonna be open at the endpoint, because intersection you don't you must share in common at the endpoint in order to get, but it's just not. So now we have FE this way, F we don't take it, and we have FG. We take it. So FG. So we're gonna have EG. So we're gonna have EG, and we're gonna have a line, because union F we don't want to take it, but they took it over here at the endpoint at F. Okay, and BG F. FE, BG, FE, BG, FE. So we're gonna have EG also. We want to find union. Okay, BG, FE, BG, FE. So we will have BG, BF, BG, BG. Okay, so this one, well, actually it's the same thing, but I can change a little bit. So BG, FE, so we're gonna BF. The same thing. Okay. Last time we have what? We have FE and FG. So we have EG. Okay. Now BC is a segment. BC segment. Union with BA. BA is also array. Then we use then we're gonna end up BC. So we're gonna put C CA as a half line as array. I'm sorry, as array. Okay. Then we have BC CF and FB. Okay. So we want to find union. BC CF. So we check C, we check F, we check B. So this is the same. This is the same. Okay, it's the same. And now we have C and CH. CH, this one. We want so this one we don't have any. Okay, let me check one more time. It can look like this is the same thing, but this union. So we check the C, but we don't check this one. We check the F, or we check here. We find all of them. We union all of B, C, C, F. Yeah, so it should be the triangle. Okay, so it's triangle. And again, I don't think they should put this question over here though, because we haven't learned any geometric set yet. Okay. All right. So that's example number 1. Okay. Okay. So in this second example, so you see that we have a compound statement over here, and again we want to see what this compound statement equal to. Then you see the second part right here. We want to calculate the measurement of some angle. Okay. So let's get started. So here we have. Let me use different color. Let me use this color instead. So we have BF. BF is array. And we have BC is also array, and we want to find union. So we want to find union, which is give you the angle. So we're gonna have angle FBC. Okay. All right. Now we have angle CBF. CBF intersect with angle BCF. BCF BC CBF intersect with BCF. Okay, so we have two angles intersect each other. BCBF, let me say CBF and BCF. So look like that we will have ray BC in common. All right, because BCF this ray over here, and CBF this. So look like that they have the ray BC. This ray go this way, and this one go that way. So we have a line. Sorry, we have a line BC in common. Then we have segment BF, a union with segment FC, a union with segment BC. Look like we're gonna give you the triangle, right? BF, FC, CB, so to give you BFC triangle. Then we have half line BH, union with HB, BH union with HB. Then we will have BH, BH, BH. This one we don't want to include it. H, BH. This one, HB. This one. So look like we have a union. So we have a ray. Now we're gonna have a line HB. Yeah. Then we have line HI and intersect with line EG. Okay, so look like we have a point F. Okay, and we have a half line CF. Okay, she included, and she does a CG go that way, and we want to find intersection CF CG. So the CC is not included, so there's nothing in common right here. Okay. So and we have angle A, so we finished first part. So now we have angle A. Angle A is right here. So angle A here. Let me put a different color. 27.6 degree. Determine the measure of complement of A. Complement is just the 90. Supplement is 180. The sum complement with 90. Complement of angle A. I'm sorry, this I put it wrong. So this angle B. I'm sorry. So angle B here, angle A right here. Oh, I'm sorry, I cannot put because angle A. There's nothing to do with this picture anymore. Okay, there's nothing to do because you see that if you put angle, there's no angle at A. So there's nothing to do with this picture. Well, now we just go ahead and calculate it. So because it's complement, the sum is 90. So the complement of A. Complement of A will be you take 90 minus 27.6. Okay, and supplement of B. Supplement is the sum is 180. The supplement of B will be 180 minus 105. I don't have calculator here, so go ahead and do it yourself. Okay. Okay. Now in the third example. Okay. In the third example, we learn to calculate some angle here based on the congruent angle we have in the parallel line. Okay, and we also talk about the vertical line already. So let's see how we're going to calculate this. Okay. Answer. So we have two lines parallel, so we have a bunch of congruent angle right here. We want to calculate the measure of angle 1 and measure of angle 6. So angle 1 right over here. Okay, and angle 6 is right over here. Okay. Okay, let's see how we do this. Okay. So let's find angle 1 first. So angle 1 is this one. And you see there's the vertical angle. So angle 1, measure of angle 1 will be 43 because the vertical angle. You see, very easy. You see, you vertical angle with this one. And angle 6, angle 6 and 117 over here is supplementary angle. Okay, so we can find angle 6. So measure of angle 6 will be 180 minus 117. Okay, go ahead and calculate it yourself, okay, because this is supplementary angle. Okay, let me see. I can include another one. What if I want to find angle 3? Okay, let's see how we find angle 3 right. Let's see how we find angle 3 right here. Okay. Okay, let's see how we find angle. I just want to add more question over there. Okay. So there's several different ways to find angle 3, but you can do like this. You see that you can look at the triangle right here. Okay. Or you can see that this one is equal to that one because a corresponding angle. Okay. So we already learned it last in the previous lecture, right? The previous video we have so this one corresponding. See, so we have corresponding angle right here. Okay, so we have corresponding 3 with this one. Okay, Let me see, and this one equal to that one. Probably it's not a good idea. Or you can do this. Angle 6 and angle this is interior containing angle. Yeah, I guess we have to do this way because we look at a triangle here. So we have angle 6 prime. So we know that angle measure. We know the measure of angle 6 prime will be 180 minus angle 6. I have to calculate angle 6 over here, guys. I cannot leave it this one. So 180 minus angle 6. So which is 117, right? Okay, or you can do it right away. Okay, you don't have to. So this is this one and this one. Because angle 6 prime is the same as angle 6. Okay, and angle 6 you can get is 180 minus 17. So you're gonna have 180. Yeah, I guess I had to calculate it. 180 minus 117. So we just give you 63. So this gives you 63 degrees. So it means angle 6 prime is also 63 degrees. Then if you look at the triangle right here, we know the sum of triangle is 180. So you can find the angle 3 prime. So angle 3 prime measure of angle 3 prime will be 180 minus 63 and minus angle 2. We already calculated. Angle 1, I'm sorry. Angle 1 is 43. Okay, so you have 63. Okay, 3 plus 43. Then you take 180 minus that, so it should give you 73. 74. Okay, degree. Then angle 3 prime and angle 3 is vertical, so angle 3 will be also 73, 74 degree. Okay, see, very easy. All right, so this is some basic information about geometries. In the next video, we'll be talking more about geometry. We will learn how to deal with the area and volume, the geometry set. Okay, I'll be seeing you next time. Bye.